how to secure OpenShift with NeuVector in a highly compliant PCI-DSS environment. Some housekeeping. Under handouts, you can download the NeuVector's ebook on 10 steps to automate container security into your CICD pipeline. This webinar will be recorded, so a follow-up email with the recording will be sent to you shortly after. If you would like a copy of the presentation or have any questions during the webinar, please feel free to write them in the chat box. Q&A will be brought up throughout the presentation and at the end. Thank you again for your attendance, and I'll go ahead and hand this off to our host, Henrik Rosendahl, Head of Business Development at NeuVector. Henrik, would you like to take it from here and also introduce our speakers?
Yes, I will. Thank you, Young. So good morning, everybody, and thanks for joining us. My name is Henrik Rosendahl. I run business development here at NeuVector. This morning, I have with me Dave Muir from Red Hat, who is leading the security ISV group, and he's going to take the first part of the presentation and talk about Red Hat OpenShift and what you can do to secure the OpenShift platform. And then I have Glenn Kosaka, who runs product management here at NeuVector, and he's going to help me with the demo as well. On the agenda, as I mentioned, Dave is going to go through the OpenShift platform and how to secure it and what security features are included in the OpenShift platform. Then we're going to introduce you to the CIS-inspired benchmark for OpenShift 4, which is a sneak preview of what is to be released. And then I'm going to give you guys a short overview of NeuVector, and also talk about how to make Kubernetes and OpenShift PCI compliant and why it is so extremely hard to do so. And then I'm going to hand it over to Glenn, who's actually going to show you how we go about things and how we make Kubernetes and OpenShift PCI compliant. So with that, let's get started. Dave, over to you.
Yeah, thanks, Henrik. So my name is Dave Muir, and as Henrik mentioned, I am the global partner solution architect at Red Hat. I focus primarily on our security ISVs like NeuVector. It's an absolute pleasure to co-present with you, Henrik, and Glenn on this webinar. Our teams have been working together very closely, pretty much on a weekly basis, right? So we're maturing our partnership, we're building awareness and collateral, and the intent is really to provide our joint customers with the right answers as they're securing their containers and DevOps processes and platforms. So today I wanted to talk to you all about Red Hat OpenShift, and specifically how security is built into our Kubernetes platform. And first, I wanted to take a quick step back and look at security at its highest level. There's several key things to think about, right? It needs to be continuous and holistic and integrated. Throughout the entire software and IT lifecycle, security needs to be designed from the start, built in as early as possible, and run on a secure platform. It also needs to be continuously managed, automated, and adapted. Another big attribute to achieve is defense in depth. This provides you with redundant protection in case one of your security controls fails. And at Red Hat, we believe that you need to start with a secure platform and then look at adding security depth with our partners like NeuVector. So let's take a quick look at the platform and talk about the value of OpenShift. It's very important to note that OpenShift is Kubernetes plus all of these out-of-the-box added services for both developers and ops teams. These added services help you build productive cloud-native apps and manage your workloads. I always think about if I had attempted to implement the community version of Kubernetes, I would need to add a lot of these services anyway. For example, I would need an operating system. I'd need monitoring and networking policies, a container registry. I definitely need some developer tooling. And if I had multiple clusters, which I know all enterprises do, I definitely would need an interface to manage those clusters. So this is the value of OpenShift. Now, one of the items here that may seem new to folks is the purple box up at the top, which is Red Hat's Advanced Cluster Management for Kubernetes, or RACM, as we've been calling it. And I just wanted to take a couple seconds to mention it. This is a brand new feature that was announced at our virtual summit back in April. It's currently in tech preview, and it gives our enterprises a single pane of glass to centralize the management of all of their clusters, whether they're on-prem or in the cloud or multiple clouds. Here's a quick screenshot, but I would point you to the day 2 keynote at Red Hat's virtual summit, where you can still go and watch all of the sessions, by the way. But in that keynote, they showed Rackham and the ability to create, update, and delete a cluster across multiple clouds and data centers, all within this central user interface. It was a really fantastic demo. Okay, so now let's jump into OpenShift and discuss what security features are built into the platform. All of the added servers that I showed a couple slides ago are designed with security in mind. This results in a lot of the security features that you see here on the left-hand side and some of the kernel-based foundational security features within Red Hat Enterprise Linux and CoreOS. And so to secure your containers at the boundaries and help you protect the host from container escapes, you'll definitely want to look at the 4 red pillars in the diagram to the right. You've got SELinux, which provides system-level mandatory access controls, namespaces, which can provide some multi-tenancy, secure computing mode, which restricts the set of system calls applications can make, and then control groups, which allows you to manage things like CPU, memory, disk I/O with one or more processes. These are the foundational features for a secure host. So let's double-click on a handful of them and start with SELinux. One of the best ways to actually achieve defense in depth, especially for zero-day vulnerabilities, is to keep SELinux enabled. Set to enforce 1, right? You'll be definitely protecting your host from your runtime vulnerabilities. And as shown on this slide, here are a couple of examples of container-related CVEs that SELinux blocked. It's basically done by enforcing a labeling system that provides mandatory access controls on every process and operating system object. So for example, if a container process hacked and escaped into the host system and tried to run a program in the host somewhere, SELinux would prevent it because the container process has a different label than the program running on the host. Now, a key reason to prove that security is built into OpenShift is that SELinux is enabled by default. And this is within OpenShift's operating systems. Now, these operating systems can either be Red Hat Enterprise Linux or CoreOS. And so I wanted to cover a little bit about CoreOS, which is based on RHEL. And it's an optimized container operating system. Because of these 3 things, it's immutable, it's self-updating, and it contains only the packages needed to run OpenShift. So we recommend running CoreOS on all your worker nodes, and this is installed and managed by OpenShift, so your admins won't really have to do much at all. Now, there are times when configuration changes are needed to the host, and OpenShift handles that through the machine config operator. So you could change configurations of some of the items listed here in the bullets, like kubelet config, registries, SSH, and then Cryo. Now, Cryo is something you want to look at next, because now that you have a secure container host, you want to look at a lightweight, stable, and simple container runtime engine. So this is Cryo. In OpenShift 4, Cryo replaced the Docker engine as the default. And one of the major reasons why was it because it improved security by shrinking the attack surface. It's a much smaller footprint because it's only focused on what it needs to do to manage running containers. So for example, it doesn't really care about building, signing, or pushing images to registries. Those duties have been farmed off to other container tools like Podman, Buildio, and Scopio. Now, we've talked about some of the key foundational features of Linux that isolate containers, like SELinux. The next question is, how does OpenShift use these features to provide runtime security? Well, this is done through a Kubernetes pod security policy, or as OpenShift calls them, security context constraints. This feature controls permissions for pods. So you can use SCCs to define a set of conditions that a pod must have in order for it to be accepted into the cluster. In this example here, you can see this is the restricted SSC in OpenShift. Pods cannot run as privileged, nor can they access the host network, ports, or etc. SECs ultimately limit the ability of the container to negatively impact the infrastructure or other containers. You may be asking, why are there two different names? Well, pod security policies, which are based on code from Red Hat, are in beta right now in the community version of Kubernetes. 5 years ago, Red Hat needed a way to deliver these capabilities to customers in OpenShift 3.0, and so it was given the name Security Context Constraints. All right, so on to networking. Within Kubernetes, you'll hear the terms network policies, SDN, or software-defined network. These technologies all contribute to network segmentation. A Kubernetes network policy is a specification like the one you see in this YAML, details how groups of pods are allowed to communicate with each other and other network endpoints. You could actually take network segmentation a step further by looking at third-party vendors to do more enhanced networking capabilities, like, for example, visualization, deep package inspection, segmentation based on layer, which, by the way, all these capabilities are in NeuVector that you'll learn about shortly. Now, one of the features to definitely look at for network segmentation is a service mesh, especially if you're building cloud-native apps in microservices. As you see here, this is one of Gartner's recommendations in their article about how to control container threats. And it's interesting to point out the last sentence here of this quote about hardening your service mesh, another feature of NeuVector. It was also interesting to read this article because Gartner points out that current commercial network security tools to segment containers are hardly delivering higher granularity than what we talked about with Kubernetes network security policies. However, Gartner did note that there was one exception, which I thought was interesting, and it was NeuVector. So let's get to the main topic of today's webinar, which is compliance. We've been talking a lot about all of these great OpenShift features that are added on top of Kubernetes, and they have security built in. But how do you ensure that these features and the platform meet these compliance guidelines? Well, as shown here, Red Hat has done a lot of work in the industry, from a NIST checklist to FSMA deployments to the payment card industry requirements, and publishing these docs. All of them are available online, easily searchable. But in the spirit of full disclosure, these guidelines are actually currently for 3.x. However, I'm happy to let folks know that Red Hat has been directly working with the Center for Internet Security to create a guide for OpenShift 4 specifically. Now, you all may know there's a guide for Kubernetes 1.15, which you can absolutely use on OpenShift 4. But this guide I'm referring to is a specific one for OpenShift version 4. Right now, it's still in a kind of CIS-inspired draft stage, but I did want to give everyone a preview of what it will contain. So if you look at the bottom here, here's an example recommendation. It says to ensure the API server pod spec file permissions are 644 or more restrictive. So the folks at Red Hat and CIS will be providing things like guidance on the recommendation, the actual audit command using the OC OpenShift command line tool, what the output should look like. There's a bunch of other columns as well, things like the validation from our OpenShift teams as they run these commands as well. Now you'll also see recommendations for all the major kube components, which are shown on the top here, like the master and worker node configs, API server, etcd, and kubelets. And there's a lot of commands to run and analyze. And while we're providing the answers here in this static document, you really want to be able to automate these checks and continuously monitor them. That's exactly what you're going to see next. When I hand it over to NeuVector, we'll actually show you this specific command plus all the others we have in this document. It's loaded and running in NeuVector. I'll hand it over to Henrik, who may have some questions for me.
Thanks so much, Dave. Appreciate the introduction here, and it's exciting to be able to preview the OpenShift benchmark. Before we do that, and before I hand over the demo controls to Glenn Kosaka, I'm just going to give you guys a brief introduction to NeuVector, but also discuss what you need to put in place to make both OpenShift and Kubernetes PCI compliant. Let's talk about how to make your OpenShift PCI compliant with NeuVector. Before we go into the details, I'm just going to give you a brief overview of NeuVector for those of you who are new to the platform. So NeuVector essentially is a full lifecycle security platform for OpenShift and for Kubernetes. We provide complete security automation starting from the very beginning with integration into CICD tools. We recently introduced security policy as code, or a YAML, which is super exciting. And we also have automated alerting and response. So every time we've seen something that is outside of the policies, we will automatically try to either remediate or alert. We have a vulnerability and compliance management platform that allows you to basically do the scanning from the very early registry when you do the pull request, as well as admission control that allows you to set up controls between your testing and dev platform and your production platform. And we're going to show you the OpenShift CIS benchmarks for the first time, which is very exciting. We have a runtime protection or production platform that allows us to look at both your network and your processes and your files and your host and your orchestrator, and make sure that everything is running in accordance with the policies that you set up. And we also have a very deep network packet inspection that allows you to look for data leaks, such as credit cards, social security numbers, patient journal numbers, etc. All stuff that you will need to make your environment PCI compliant. And then finally, it's a true cloud-native solution, so it deploys and updates as any other pod will. So NeuVector in itself is just a pod that sits on every node, and it's deeply integrated into both OpenShift as well as a variety of different tools here. Let's talk about PCI compliance and what you need to do. I mean, first and foremost, this is all about protecting cardholder data, right? So this is a sort of a security specification made to protect people, with online credit card data. And so while it's not specific to Kubernetes or to OpenShift for that matter, it does list a number of things that you must put in place in order to be PCI-DSS compliant. First and foremost, you should build and maintain a secure network, which is why we're here today and talking about it in detail. You must be able to monitor and test your network, and with that comes adding visibility into your networks, both north-south as it pertains to in and out of the internet, or to existing hosts, as well as east-west traffic inside the Kubernetes cluster. You should maintain a vulnerability management program. So from the very early days in the CICD pipeline, you should manage your vulnerabilities all the way through to production. And you should implement strong access control. And Dave mentioned that briefly with the OpenShift RBAC. And so that is, of course, a part of making your environment PCI compliant. And then finally, you're going to maintain a security information policy. That means that you need to have good locking in place and good change controls in place. So you can do rollbacks, and you can also see who changed what. So let's talk about why PCI is so hard with Kubernetes and containers. As you've probably come to know, there is an awful amount of east-west traffic, network traffic between all the pods in Kubernetes. And so the amount of network connections that you're dealing with is simply exploding. And that's just further it's further exacerbated by a service mesh as well. So you have an awful lot of east-west traffic that you need to you be aware of. And you also have this ephemeral nature of containers, right? Some containers only live for a few seconds, some will live for 10 minutes, maybe an hour, but this is a very, very fluid environment. And that makes troubleshooting extremely difficult. Chances are that whatever container failed or was attacked or compromised does not exist anymore, right? So it's really important that that you have some good locking in place. And in the case of NeuVector, we actually quarantine a container instead of shutting it down, so you can SSH into it and see what happened to it. Rapid changes in DevOps, right? This is all about pushing code into production as quickly as possible, and combined with number 4 here, which is extensive use of open source. You are vulnerable to attack vectors that are coming from the open source libraries, and you may not be able to see it, or you may be forced into a situation where you have to run an application in production knowing that there are high priority vulnerabilities. We're going to talk about how virtual patching is going to help with that a little bit later on. We're talking about the low visibility into the Kubernetes network. It's by itself fairly hard to monitor, and so NeuVector provides visibility into that. And then, of course, Kubernetes, I think it's its 60th birthday today. Help me out. I saw that on the news this morning. And so it's a relatively immature platform, and it's an evolving platform. And so there will always be vulnerabilities associated with these types of platforms. And so you need to hedge against that. So what are your options out of the gate to make your environment PCI compliant? Well, you can basically maintain all your cardholder data in a traditional environment and simply not handle it with Kubernetes. That's sort of the not very exciting option, and probably not why you're here today. You could also put your cardholder data in a separate Kubernetes cluster and manage that with your existing firewalls. That is sort of the very old school way of doing it. You're basically just allocating a full cluster to cardholder data and then tromboning all the traffic to an existing hardware firewall. Or you can use NeuVector as a Kubernetes native firewall and then enforce the segmentation and firewall rules inside the cluster, as you can see here on the graph to the right. But let's start with the first things first. You must build and maintain a secure Kubernetes network, and so with that, you need to provide a real-time network diagram that is not based off IP tables, but is a real-time depiction of what's going on in your network, both from an east-west perspective as well as a north-south. Speaking of north-south, you need to restrict all the inbound and outbound traffic to the internet, such that nothing else than say a Nginx load balancer or similar will be able to talk to the outside world. That's a part of the PCI-DSS standard. You also should restrict all unauthorized connections, also known as whitelisting. So no pod can talk to another pod unless specifically allowed or specifically whitelisted, right? That is really cumbersome to do without a tool like NeuVector. You can do some of it in network policies, but as your application grows, it becomes really cumbersome and really hard to maintain, and then chances are that you're going to be making mistakes down the line. And NeuVector, for instance, automatically creates a policy by observing the traffic before you go into production, whitelisted, locks it down, and will basically deny all other attempted network connections from that point out. You also need to create internal segmentation zones with the cardholder data, and you can then safeguard those zones with data leakage prevention, such that, as you can tell on the picture to the right, we will look in the network traffic. We will do a deep packet inspection and make sure that no cardholder data, social security number, driver's license numbers are escaping those zones. Those, that network inspection is sort of safety net, if you will, around the zones. Other important PCI compliance measures that we mentioned already. End-to-end vulnerability management is really important, starting from the early part of the CICD pipeline. Keeping up with your patches and patching both the host as well as Kubernetes and Openshift is super important. Configuration checks, like we're gonna show you here in a minute, and making sure that your platform is appropriately configured and you're not missing something is a part of it. And then virtual patching, which I find super exciting, is essentially acknowledging that, you know, at some point you will be forced to running vulnerable applications in production. And if you don't have time or don't have access to a patch that takes care of the vulnerability, you can safeguard your application and your vulnerability with security policies around it, specifically network policies, to essentially eliminate the potential threat of that vulnerability. And Glenn will show us that. And so one of our customers, common customers between Red Hat and NeuVector is Experian. You can see just a screenshot of one of their applications to the left, and you have John Deming here on the right, talking at the Red Hat Summit about how he's implementing NeuVector and Openshift to safeguard the applications that he's running. And the screenshot you have here on the left is it's a reasonably sized application, but nothing crazy. And you can see there are thousands of network connections and hundreds of containers that are communicating, and so it gets very, very unruly very, very quickly. I encourage you to just Google this session with John, Red Hat Summit, John Deming, Experian, and you will get his full session there. So before I hand over the controls to Glenn for the demo, I just want to talk about why network inspection is so critical in attack prevention. If you look at some of these like known attacks, you've seen Bitcoin mining, you've seen the Equifax data breach, there are the DDoS attacks, SQL injections. Most of them, 90% of all attacks and hacks have a network component to it. It's either the weaponization or the data exfiltration, right? That will have some network component. And so if you lock down your network really tight, chances are they're not going to get in, and chances are they're certainly not going to get out. So that's really why in the PCI compliant environment, a network policy like NeuVector is so important. With that, Glenn, do you want to take it from here and show us a demo and also talk about the virtual patching?
Sure. Thank you, Henrik, and thank you, Dave, for those great overviews of Openshift and NeuVector and the importance of defense in depth. So first, as Henrik mentioned, virtual patching is an exciting topic, and it's basically the concept that as you go through your vulnerability management program, you're going to have all kinds of detections of perhaps hundreds of vulnerabilities. And for a great many of those, there is not a vendor fix available to patch that. And for others of those, they may be running in production, and it may take you a few weeks, a few days, maybe even a few hours to put that back into your pipeline, update the image, run it through your test cycles. And even if you're fully automated, it's going to take you a few hours at least to be able to replace that running pod with one that's not vulnerable. So the concept of virtual patching is really preventing that vulnerability from being exploited once it's in production. In other words, virtually patching it. And in order to virtually patch it, you've got to be able to protect that pod from being exploited on the network, like you heard from Henrik, You've also got to be able to monitor all the process and file activity within that pod, and then prevent any unauthorized process or file activity. And so that is the concept of virtual patching. And I will show you that in just a minute. So I'm going to start with the general NeuVector console, which you're looking at here. And before we get into the some of the details and the highlights that Dave and Henrik talked about, I'll talk a little bit about the infrastructure we're looking at. So if I go to Assets and Nodes, you can see that I've got a Openshift cluster. It's got 3 master nodes, 2 worker nodes. You can see it's running RHEL Core OS that Dave mentioned with Cryo. So all the latest stuff here. And when NeuVector is deployed, we deploy our control plane into this cluster with our controllers, and that manages what we call our enforcers. And these are just containers or pods, and the enforcers get deployed as a daemon set. So once this is deployed, then we're able to do all of the vulnerability management, compliance management, scan everything in the environment, as well as do all of those runtime and network firewalling protections that Henrik talked about. So why don't we start with the exciting new tech preview that Dave and Henrik mentioned, and that is the CIS-inspired Openshift benchmarks for compliance. These are similar to the Kubernetes CIS benchmarks. So for the first time, this is the first time anyone is seeing these brand new benchmarks implemented in an automated security tool. So if we go, we're on the master node now. We're looking at the compliance report for this master node, and we can see these compliance checks that have been automatically run. Now, anytime another node is added to the cluster, whether it's a master or worker node, NeuVector will automatically run the compliance checks as well as scan it for vulnerabilities. So here you can see the check that Dave highlighted, and the description of that, the API server pod with permissions 0644, and you can see that has passed. If it didn't pass, you could see a warning as well. There's a couple other aspects of Openshift benchmarks that are slightly different than your typical Kubernetes ones. There's an overall score that can be used to calculate your compliance score. And some of these checks are critical enough that if they don't pass, they will either positively or negatively affect that score. Others are more recommendations, so they're not going to affect the score. So that's what this scored column means. Also, there's a profile level. There's 2 levels. Level 1 is for, I would call them basic hygiene, basic security hygiene. So these are things that you should be looking at to enforce basic security controls. Now, there are level 2 checks, which think of them as more advanced security checks that provide you additional levels of defense in depth that Dave talked about. So those are what you can see with the CIS benchmark. It's very exciting stuff, and we're working with the Openshift community as well as contributing to the CIS org to fully get these adopted as an official CIS benchmark with Red Hat. Okay, so in addition to the compliance checks, as Henrik mentioned, we also do an end-to-end vulnerability management solution. And that starts with the build pipeline, where whatever build tool you're using, whether it's Jenkins or some type of Azure DevOps or GitLab or any type of pipeline tool, Circle CI, you can invoke a scan of the image during that build process. And if it's got vulnerabilities, you can kick it back to the developer and require them to patch that before it goes further in that pipeline. And once it passes your pipeline, typically you're going to put that into a registry, staging that and making it ready for your production, deployment to production. And again, that's where NeuVector can be configured to scan and monitor your registries. So what we're able to do here is to scan registries and repositories you've configured and do what's called a layered scan. So in this Node.js image, you can see that we have 60 high vulnerabilities, and we show you a layered kind of dissection of that image. We're able to show you that at this layer, there are 4 of these high vulnerabilities were discovered. Here's the build command that was used to create that layer, and it makes it easier for you to get back to the developer. Also note that in some cases there is a fixed version, but as I mentioned, there are some vulnerabilities where there is not a fixed version, for example, like this one here. Now, one of the cool integrations we have, in addition to supporting a number of registries, we have a special integration with the Openshift registry. Openshift supports what's called image streams, and that's kind of a push notification whenever there's a new image or updated image in your registry. You can turn auto scan on, and NeuVector will automatically scan that new image every time it's added to this registry or repository. For other registries that don't support that, you can turn on a periodic scan, and NeuVector can scan that for new images every 5 minutes or every week, as often as you'd like it to be scanned. Now, the importance of allowing NeuVector to do this scanning is then you can tie those scan results to a runtime policy. And so what you can create is an admission control rule, which enables you to protect deployments into your Kubernetes infrastructure. So for example, if I want to block all deployments, so I want to say, if there are any high severity vulnerabilities where there's a fix available, so even if there's only one, I want to block this deployment. So what this is going to do is it's going to, anytime OpenShift is deploying a new container deployment, it's going to webhook, it's going to stop that deployment and webhook to NeuVector and the API server. And the NeuVector controller is going to evaluate these rules, and it's going to say, oh, this image is trying to be deployed. Does it have a high vulnerability where there's a fix available? And if it exists, it's going to block that deployment. Now, if there's no fix available for that vulnerability, in this case, for this policy, it's going to allow that deployment. And then again, in the runtime environment, virtual patching will take control of protecting that container once it's running. You can see that in addition to criteria based on vulnerabilities or specific vulnerability names, you can have other things such as identifying an allowed production image registry, don't allow images that have not been scanned, don't allow privileged or running as root containers, etc. So this is an important security control to protect your runtime environment. And then once in the runtime environment, whether it's a host where we're going to scan for vulnerabilities, Red Hat's doing a great job. There are no high vulnerabilities on these hosts, or in a container like this Nginx container, we're going to scan that for vulnerabilities and also run any embedded or custom compliance checks that you've configured. So all of that is going to be summarized in, as Henrik mentioned, an end-to-end vulnerability and compliance management tool that we provide. And what this is going to give you is the ability to easily scan your vulnerabilities. You can filter them, for example, those with fix, without fix, or levels or namespaces. And you can see that this vulnerability here has some red there on the impact. If I click on it, I can see the fixed version, I can see that it's found in these images from the registry scan, and it's running, this vulnerability is found on these hosts, and it's found in these running containers. Now, there are some that are red and some that are green. This is where virtual patching comes into play. If these containers are running with the NeuVector protection on, in other words, we're monitoring the network connections, the process and file activity of those containers, we've whitelisted them, and anything else is going to be blocked. It's going to be green because they're virtually patched. If the protection is not on, in this case for the hosts, it's going to be shown in red. So it's a way to alert you immediately of potential areas in the runtime environment that could be more vulnerable to an exploit risk. So this is a great tool for managing not just vulnerabilities, but compliance results as well. And so we provide this screen to be able to generate reports and evaluate all of the compliance OpenShift checks that we just talked about. All right, so now that we've talked about compliance and vulnerability management, the next major topic that Henrik talked about was creating a network to segment your traffic, your CDE and your non-CDE traffic. So once NeuVector starts to run, we'll discover all the running containers, and we will automatically see these network connections. For example, Nginx is talking to Node using the HTTP protocol. We will automatically create a segmentation rule, number 259, to allow only HTTP traffic between Nginx and Node. We will then also see this traffic from Node.js to Redis containers. And similarly, we'll create a whitelist rule 198 to whitelist only the Redis application protocol. And in this way, we are able to lock down the environment so that any violations of those network rules are alerted. And in the case of if you're running in our protect mode, they're actually blocked. So when you're running in a protect mode, we're like an inline firewall, and this attempted lateral east-west traffic violation from Node.js to Node.js, which is not allowed by a whitelist rule, has been blocked. And Henrik also talked about managing ingress and egress connections as a way to manage PCI compliance. So in this case, we see an unauthorized external connection. This could be an attempt to hack into one of your apps, retrieve PII data, and then send it to a command and control server. In the case of running in protect mode, we can block those. In the case of running in monitor mode, we'll just alert you. Now, you probably will have instances where you do need to allow connections to an external API service. In this case, we're just allowing it to Google. But we've created a custom egress connection rule that allows encrypted connections between this Node.js pod only to google.com using an encrypted connection. So in this way, we can make sure that the stipulation that credit card data be protected at rest and in transit is also enforced if your applications need to transmit CDE data inside or outside the cluster. So that's a quick snapshot of some of the network rules. And as Henrik mentioned, not only do we look at the network rules, if I go to my container deployments and I look at my demo namespace, I look at my Node.js containers, you can see a summary of those network rules. You can also see all processes that we've discovered running in these containers, and these have been whitelisted. And you could see any customized file activity rules. So all of these are going to be enforced by NeuVector in a production environment. Now, how do you manage these? How do you prove to your auditors that you do have these protections in place? Well, you can take a screenshot, you can export these rules. The best way and the best practice for doing this is what Henrik talked about as security as code. And that's where ultimately you want to use NeuVector to learn all the behavior of your containers, but then you want to capture that as code. So what we're going to do here is, let's say, and this is my staging environment, I have captured all the behavior of my demo stack, and I'm going to now export that as code. And so this will export that as a standard Kubernetes YAML file, implementing a custom resource definition, which is in the NeuVector format. It looks like this. And you could see here that it's a typical Kubernetes declarative statement, but it's specifying all the things we looked at. And Nginx in the demo namespace can use the HTTP protocol to talk to the Node.js pods, and these are the processes allowed to run in there. Google, it can access google.com, but it needs to be using the SSL protocol, et cetera, et cetera. So we've captured all of the security rules. We can now use this to review this with our DevOps team and developers, edit it, check it in as code, and this becomes the security policy of record that I want to deploy and push to production. So I'll show you a quick demo of that. So you can see here I've got my terminal view of my cluster. If I just show you my NeuVector pods running, you can see I've got my controllers, my enforcers, and my demo pods running. And so what I'm going to do here is I have created a file from that export that we just took a look at. And it looks like this. Now, the only thing I've done here is I've changed a global change of the namespace from demo to production. And so I have a namespace called production. Let's say I'm going to deploy that into my production environment. So and I can edit this file to eliminate processes that shouldn't run. For example, I see curl running here in my Node.js pods. We use that just for demos and tests, so we can get rid of that if we want before we deploy. So this is the security policy of record, and in order to deploy this, I simply deploy that just like I would any OpenShift or Kubernetes object, and you could see that I have now created those rules here. So when I go back into my NeuVector console and I refresh my view, so now I can see rules that have shown up that are CRD created. I have now created let me go filter again for my demo namespace. I have now created CRD rules for all of my policies. So for example, that Google rule that I just added has been deployed. And you could see that that was deployed using that security policy as code. All right, so that's a quick demo of the policy as code of NeuVector. One last thing I should mention is these cannot be edited in the console like other rules. You have to actually check out that code and edit it. So I think that's a good tour, good high-level overview. If you want to get other best practices for automation into your pipeline, in the handout section of this of your console here, you can download an ebook on 10 steps to automate security into your pipeline. So with that, why don't I turn it back over to Henrik to wrap up.
Right. So we often get the question, what's the difference between OpenShift, Service Mesh, and NeuVector Security, and how does this all tie in? And so we try to come up with a fairly sort of straightforward table that highlights who does what and when. And so as you can tell here, the OpenShift security features are really sort of platform security measures at its core. And then, of course, implementing network policies on layer 3 and 4 is sort of Kubernetes networking. We often also get the question about, Istio or various other, forms of service meshes. doesn't that provide security? Well, it provides sort of service routing, and it provides service encryption, and as well as authentication. So in some sense, yeah, it does provide security, but it does not actually do any sort of proper layer 7 deep packet inspection. It doesn't do any process detections of file system monitoring, et cetera, et cetera. And it doesn't do any sort of threat detection and packet capture and that kind of stuff. And so this is kind of a broad stroke view of what the different types of security solutions are doing. And in order to have a fully sort of PCI compliant environment, you would actually have to implement OpenShift and NeuVector, OpenShift Service Mesh and NeuVector, but you would need to have a layer 7 network security solution in place to do that properly. So with that, we are on the summary slide, and I got a few questions here for Dave, and feel free to ask any further questions in the questions and answers prompter in the go to webinar console here. So Dave, are you still hanging in there with us?
I am. Yeah, this is all good stuff.
Good. So I've got a question for you. When do you expect the OpenShift 4 CIS benchmark to be published? Good question.
Yeah, good question. Well, I can't give you a solid date. The hope is, in about a month or so, and yeah, so we've been working really hard with CIS to get that done, but obviously timelines are tight. And yeah, hopefully in a month.
Okay. All right. There's another question about IAM and RBAC here. What does that add? What does OpenShift add to Kubernetes for those features?
Yeah, good question. I didn't really go into depth there, but so IAM is the authentication piece within Kubernetes, identity and access management. With OpenShift, it comes with a built-in OAuth server by default, and it supports a number of identity providers like GitLab and GitHub, and LDAP, a handful of others as well. RBAC is the authorization piece, or role-based access controls. Basically determines whether a user is allowed to perform a given action. The thing that OpenShift provides on top of Kubernetes is that RBAC is enabled by default. With community Kubernetes, you actually have to enable it with the authorization mode flag when you start the API server. So.
Okay, and I got a license question here about OpenShift. Why do I need a license to run OpenShift since it's open source?
Oh, yeah, it's a very common question. This is really a discussion around the benefits of the Red Hat subscription. So we don't actually sell licenses; we sell subscriptions. It's typically a yearly subscription, and so we have to earn our customers' business every year. But with the subscription, you get a handful of benefits. One is technical support, 24/7 support. One interesting thing with support is if you're dealing with OpenShift and another one of our vendors, we have what's called multi-vendor case ownership. So that means that Red Hat will take the lead in contacting those third-party vendors for you. You also get stability with our product. We've got a 10-year life cycle. You get the patches and updates. You get the security updates and patches that we were talking about. There's also a lot of sort of expertise resources at your fingertips. So we have a customer portal and forums, a knowledge base, and you get access to certain labs. And then you've got Red Hat commitments around hardware certification, software certification. So there's just a handful of items that our customers benefit from with our subscriptions.
Okay, that's good to know. Thanks, Dave. Glenn, I got a couple of questions for you here in the console.
Okay.
Does Istio do layer 7 network security? That's the question.
Yeah, it's a good question. Dave talked about service mesh for encryption, authentication, authorization, and other features. The way to think about it is NeuVector, definitely, first of all, you should turn on the encryption because that's very easy to do for pod-to-pod encryption of Istio if you have the horsepower to, have the sidecars all doing SSL connections or TLS connections. Think about it as, Istio is great for, think of it as like a load balancer, right? You need both a load balancer and a layer 7 firewall because a load balancer is great for content-based routing connections and the ability to do blue-green deployments and other very cool stuff. But you'd never use it as your attack prevention tool and network visibility for threats in progress. So think of NeuVector as that. And all of the capabilities that I showed in looking at the network connections and protocols and DLP for that matter, deep packet inspection, are available from NeuVector, even if you've deployed a service mesh and you've turned encryption on, because we can inspect and intercept the traffic before it goes from the application workload into the sidecar proxy to be encrypted. So you get the best of both worlds with Istio and NeuVector. In addition to that, as Dave mentioned, we can also kind of harden the Istio deployment where we will monitor all the network traffic of all of the control plane, all those additional containers, all the sidecar proxies that are running. Those could be attack points as well. So we will monitor and protect those as well.
Okay, and then associated with that, what type of performance overhead do you see when you're doing deep packet inspection?
The deep packet inspection, so as I mentioned, there's a monitor mode, and that's more like a network tap, so you can run at line speed. There's no overhead, and we'll just alert you if we detect a network violation. On a container or service by service basis, you can choose those which you want to run in the inline protect mode, and that's where it's a blocking inline firewall. And for those, there's a very small single-digit percentage, 2 to 3% typical overhead in latency and/or additional, CPU consumption. And of course, as always, your mileage may vary. It depends on the type of connection, the type of packet, how large the payload is, and are these a lot of short connections, or are they more longer with a larger payload connections?
Okay, good to know. We're coming up to the top of the hour, but I have one question left here. You mentioned CICD tools. What tools do NeuVector support?
So the tools I mentioned that are typically used in the pipeline or CICD process are like a Jenkins plugin, Azure DevOps plugin, Circle CI, or GitLab. A number of plugins that we have to do build phase scanning. In addition to that, some of our customers have chosen, even they're using Jenkins, to use our REST API to trigger the scan during the build, because they want to do more customized responses, like they want to check if the fix is available, and they want to parse out the owner or the developer of that image in the response from our scan, and then they want to automate the notification of the developer to let them know that they've got to rebuild that image. So for any part of that pipeline where there isn't a plugin, there's a full REST API to be able to do that as well.
Okie doke. Glenn, I think it's time to wrap up here. As we mentioned earlier, there's an ebook you can download from the GoToWebinar console. There's also a PCI guide on the NeuVector website. And Dave, thank you so much for joining us this morning. That was very informative. And we're excited to be able to show the Openshift CIS inspired benchmark.
Yeah, very exciting. Thanks, Dave. Thanks, Henrik.
Lovely. Thank you all.
Thank you guys for joining us.
All right, thanks for joining.
Thank you all.
Have a great day.
I know.